Okay, so I want to just go over how this is all going to tie together. And so we will set up a story problem, and this is page 136 in your book, called Example 1, Canoe Rentals. So, all right, basically what we're going to do is we're going to set up our chart or our story problem. Then what we're going to do next is graph it and shade it. Then we're going to look for the corner points because those are going to be our maxes or mins. Then we're going to make the table and figure out, at this point what the value is, at this point what the value is, at this point what the value is, and so forth. And then we look for the maximum or min value. Then we answer the story problem, like you should do this to maximize profit at this amount, or you should do this to minimize cost at this value. Okay. All right. Now, these story problems still are kind of the noun, 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 verb, verb, verb type. But a lot of times they're one alone, the other thing alone, the things together, and then some type of value with that. But this one doesn't fit that pattern, but some of the other ones we do will. All right, let's read it. Now, my advice to you on this is get rid of the Z, the max or min first, okay? So, and usually that's at the end of the story, so to speak. So if you read the story problem, at the end, it says, how many canoes and how many kayaks should he buy to earn the most revenue? All right, so we know they're trying to maximize revenue. So on the top of your paper, you're gonna write max revenue, and you're going to put Z equals, because the Z is not anything you're going to graph. That's what you're going to do when you get to the table or the chart. All right. So look for any words that talk about revenue. All right. If I skim through this, it says the canoes will rent for $25 a day, and the kayaks will rent for $30 a day. So that's the money he's going to be bringing in. So canoes are $25 a day. So I'm going to put Z equals 25x plus, and then the kayaks he can rent for $30 a day. So 25x plus 30y. And under the 25x, I'm going to write canoes. And under the 30y, I'm going to put kayak. So I know that those nouns go at the top of my chart. I also know do not use 25 or 30 in your what we call the constraints. This is called the objective function, because that's our objective. Our objective is to maximize this Z equals 25x plus 30y. All right. So what goes underneath it? Well, usually a total, a value, maybe a total alone, a value alone, something like that. All right. So let's read. Do they give us a total? Well, how many can his facility can hold up to 65 boats, sorry, not votes. That's a total. So underneath in my chart, I'm going to put X plus Y, and what was it? 65. Now, like our last story problems, it's going to be, again, kind of a chart. That's a total. And I have X plus Y. Now, I can't use equals 65, though, because that's not reality. He doesn't have to buy exactly 65 of these things. He could buy less than or equal to 65 because he has storage for up to 65. So he can buy up to 65. So X plus Y less than or equal to 65. All right, let's look for a value on this one because usually there's a value. All right, how much is he spending on these? He can buy canoes for $600 each and kayaks for $750 each. All right, so in my chart, I am going to write 600x plus 750y. Now, how much money does he have to spend on these things? He has $45,000 to purchase new boats. So I'm going to write 45,000. Now, again, what symbol? It's not going to be equal. He doesn't have to spend all his money, but he has a budget. So the 600x plus 750y has to be less than or equal to that budget. All right, and I think we've used everything in there. Now, the ones that shall never be forgotten, kind of like Harry Potter, like the one that shall never be named, right? X has to be greater than or equal 0. Y has to be greater than or equal 0, because you can't have negative boats, negative kayaks, or canoes. That doesn't make sense. Okay, so don't forget those. Okay, these are called our constraints. All right, next thing we're going to do is we are going to graph these. Now, these are some big numbers here. So let's make our XY chart to kind of see what our graph paper should look like. If I sub in 0 for X, I get 65 for Y. If I sub in 0 for Y, I get 65 for X. And we're just using X intercepts to graph these. The next one, X and Y, we're going to sub 0 in for X. So I'm going to get my phone out here quick. Come on, Face ID. There we go. All right. So if I sub in 0 for X, I have 45,000 divided by 750. And that is 60. And on the second inequality, if I sub 0 in for Y, I get 45,000 divided by 600, which is 75. All right. So if I was going to graph this like perfectly on graph paper, I would probably see how these are by fives. I would probably graph by 5. So like 5, 10, 15, 20, and so forth, just to fit it on there. All right. I am going to just make a sketch of a graph. All right, because I'm going to use DESMOS to help me out. Now, these two tell me that I'm in quadrant 1 because X is greater than 0, Y is greater than 0. So I'm not going to shade, but I'm just going to draw arrows that I am in quadrant 1. So those two are done. So cross those off. I did those. The next one is 65 and 65. So I am going to put a point at 65 on the Y and 65 on the X, and it is a solid line because it's equal to. And then I'm going to test 0, 0. Is 0 plus 0 less than or equal to 65? The answer is yes. So I'm going to draw arrows going down towards 0, 0. So right now I have a shape of a triangle. Okay. All right. The next one is going to cut it into A and B. All right. So 0, 60 on the Y. So I'm going to put a dot or a point at 60 on the Y. And there's a point at 75 on the X. So that would be over here a little bit. And again, I know this is not perfect. And I'm going to cross there. All right. So it cut off this little top part here that was in the shaded. So there's an A and a B. All right. Now I can test 0, 0 again because it is not on that line. So is 0 plus 0 less than or equal to 45,000? The answer is yes. So I know A is a no. I'm in this region right here. Okay. Now, where does this point cross? Because you're like, Julie, you did not make real graph paper, and I did not. Okay. So what I'm going to do, let me pause for a second. I'm going to go on to DESMOS and show you how you can use DESMOS as a tool, not a crutch, but a tool. Okay. I just grabbed these as lines. I'll graph them as inequalities in a second. So I did X plus Y equals 65, graph that, 600X plus 750Y equals 45,000, X equals 0, Y equals 0. And really the point that I couldn't get on mine because I didn't graph it well, right, is this point right there, which is 25, 40. Now, I think using this as a tool is great, but the problem is when you graph it, sometimes it gets too busy. All right, so let me change X to, and I have to use the toolbar. X is greater than or equal to, Y is greater than or equal to 0. And then I'm going to go X plus Y has to be what? Less than or equal to 65. And 600X plus 750Y is less than or equal to. So if you pay attention to how DESMOS shades, then you can, kind of know where you're at. But if that it can get kind of busy if you have like, say, 6 different inequalities in there. But you can use it to help you get the corner points and to be accurate on your graph. All right, I'm going to pause again, and we're going to go back, and we're going to make the chart, and we're going to solve the story problem. All right, the other thing I was going to show you is you could do matrices to see where those two lines cross as well. So 165, 600, 750, 45,000, and do RREF, and that will spit out that they cross at 25, 40 as well. All right, I am going to go back to our lovely graph. And again, this is just a sketch. It's not perfect. All right, so then what we're going to do is we're going to take our corner points. Now, there's lots of points on this graph. The only ones that count are the ones that are touching the shading. So you might have extra points that you use to graph the lines. Those aren't corner points. It has to touch where you shade it. So we have corner points at 0, 60 on the Y, 24, 40. Then on the x-axis, 65, 0, and then the corner 0, 0. All right, so the next thing, now we're ready to use our Z. So we have these 4 points that I just read off. We're going to put them in our chart for corner points. Then we're going to sub them in to 25x plus 30y and figure out what answers they give. Okay, so you're going to type in, well, 0 plus 0, 0. If you do 0 for x and what, 60 for y, that's going to be 1800. If you do 24 times x, I got a doggy here I have to let out, and then 40 for y, then we're going to go ahead and figure out what that is. And then 65 for the x, so 25 times 65 plus, and then 0 times y. So I'm going to pause and do these two on a calculator. So all I'm doing is subbing in for the x, subbing in for the y, and then doing the math. So I'm going to pause a second and I'll calculate those two. And then we'll write our final answer. All right, so I type these in a calculator, let it do order of op for me, and I notice that this is the maximum. So this answer is going to give him the maximum revenue. So then I come down here and I say he can maximize revenue by purchasing, well, what do I want him to purchase? 24 canoes, 40 kayaks for a maximum revenue of $1,825. And then I answered the story problem. All right, I am going to pause and we're going to try to set up another one here quick. All right, this one is on page 142 in your book. So let's look at this one. Again, first thing you want to do is read the end of the story. You want to get Z. All right, so it says, how many engines should be shipped to each plant to minimize shipping cost? Okay, so that's our Z. So we're going to get that at the top. Z is minimize shipping cost. So anything you read that deals with shipping costs, that's going to be an RZ. All right, so what does it say about shipping costs? It costs $30 per engine to ship to plant 1 and $40 per engine to ship to plant 2. So at the top, you're going to do Z equals 30x plus 40y. But that also tells you what nouns go at the top, because it says $30 to ship to plant 1. So you know plant 1 goes at the top under the 30x, and plant 2 goes at the top under the 40y. All right. Now, this one is going to be a typical one where you have one alone, another one alone, the two together, and then some type of value. And don't use that 30 and 40 again. They are gone. Okay. So let's read. It says plant 1 needs at least 45 engines. Plant 2 needs at least 32. Those are alone. Okay, so plant 1 by itself needs at least 45. So you're going to do X greater than or equal to 45, because they need at least. They will take more. All right, if I told my husband I want to have at least 3 kids, then I'm okay with 3 or more. Or if you want to make at least $40,000 a year, you're okay with 40 or more. The other one is by itself, it says needs at least 32. So you're going to write Y is greater than or equal to 32. Now, what about together? Well, it says, where does it talk about them together? The company can send at most 120 engines to these assembly plants, 120 at most. So this is together, X plus Y. Now, this is less than or equal to 120 because this is at most what they can do. And then the value is they have these rebates. Let's see, Myers $20 in rebates towards its products for each engine, while Plant 2 gives a similar $15 rebates, and Myers estimates that they need at least $1,500 in rebates. So that would be what? $20 rebate, so 20x plus 15y, and they need at least $1,500 in rebates. And then the last thing is, do not forget the ones that shall not be forgotten. X and Y cannot be negative. They have to be positive values because, you know, we're talking about items here, and things that are being shipped can't be negative. All right, next step would be to graph these, okay? So we're going to do that in the next video, but that's kind of the whole setup, and this is very, very common.